Okay, here we are on day 37, the second part B. We're going to be solving systems of linear equations again, which means finding the intersection of two lines that are made by two linear equations. So this first problem here, it says find two pairs of coordinates for each equation by making a t-chart. Use the coordinates to graph the line and find the solution, the lines and find the solution. Okay, so this is like what we've been doing in part A. Make this a little bit bigger. Okay, y equals 3x minus 15, x plus y equals 13. So let me graph the first one here first. Y equals 3x minus 15. So I know the y-intercept is minus 15. Which is 12. Boy, they put that way down here. Around there, I guess. Minus 15. And the slope is 3x. So I want to pick a different one. If I pick a, let's say I picked 5. If I picked x equals to 5, right? 5 times 3 is 15 minus 15. Y would be 0. Well, that's a nice number. So I'll do 5, comma 0. But whenever I pick a nice number, it often turns out that that ends up being the point of intersection. Well, let's see what happens here. So we're way down here, minus 15 and 5 comma 0 right there. That don't look so good, does it? Now I'm using a pencil. I should have used my pen. Let me try that again. Still looks like terrible. Oh, no, it looks okay. It's just the reflection. Okay, other equation. X plus y is 13. Okay, I could change that to y equals 13 minus x, or minus x plus 13. Okay, the y-intercept is 13 this time. 12, that's right at the top. When x is 0, y is 13, right? Let's pick another one. How about, I don't want to pick 5 again because that's too close to this one. Let's pick 3. So when x is 3, 13 minus 3 is y is 10. So 3 comma 10, 1, 2, 3 comma 10 is right there. Right? And so actually, I'm using my pen. If we take that line, we get an intersection right over here. Where is that? I don't know. That's like 6.5 comma 6. About 6.5 comma 6. That's the point of intersection. Again, it's more or less an estimate because it depends on the accuracy of how you drew your lines. Anyway, that's what I'm getting. I could check these answers. I could put 6 comma 6 in here and see if they come close. Well, let's try that. 6 times 3 is 18 minus 5 is 3, but I have 6. So it's not very accurate, is it? This one, 6 and 6 is 12. 6 and 6.5 is 12.5. That's pretty close. This one here wasn't that close, so 18 minus 15 is 3. Yep. Okay. Let's go to number 2. Again, this is a way of estimating. It doesn't give you a really accurate thing, especially if you made any mistake. It won't be that accurate. Okay. So the one on top, I'm going to divide by 2 because these are all even numbers, and that gives me 2x plus y equals 10. And I'm going to put the x on this side, so I get y equals minus 2x plus 10. And that gives me an a y-intercept. When this is 0 times this, it becomes 10. A y-intercept of 10, comma 0. And let's say I put a 5 in here. If I put a 5 times minus 2 is minus 10 plus 10. I get my 0 again. I like that. 5, comma 0. So there's my first line. Okay, other line. So this is already set up in the right format, slope-intercept format. So if x is 0, we get minus 4. 0 minus 4. And if x is, let's say, let's do a negative number here because we're going to be subtracting. So we'll get a negative times a negative. That'll make it positive. So if we put x negative 2 in here, negative 2 times negative 5 is 10, positive 10. 10 minus 4 is 6. Negative 2, 6 is here. Now, you can see these almost don't even match. Let me check the slopes here. If they don't match, this is slope of negative 2. This is slope of negative 5. They're both pretty steep. But you see what's happening. It's going off the chart. The intersection is off the chart. I'd have to extend this one to get the intersection. Which tells me they didn't do a good job of picking lines that would even be on our chart. So this is going to be, like, I don't know, negative 3 or negative 3 at least. And maybe 15, 16, negative 3, comma 16 as the point of intersection, something like this. That's pretty big, negative 3, 16. Let's see what that is. That's 15 minus 4 is 11. Yeah, not that close. Negative 3 is negative 12 plus 32 is 20. Yep, they're not even that close. They don't even come out that close. Anyway, not very accurate way, but that's how we're doing it, intersecting two lines like that. Okay, now we're going to move on to substitution. Find the solution for two equations by substitution. Express as ordered pair in the form. Okay, so we're going to be doing substitution. I'm going to have to work right on my whiteboard here. Not much room here to write. So we got negative 7x plus y equals 22. Negative 7x plus y equals 22. And what's the other one? 4x plus 2y equals 10. 4x plus 2y equals 10. Now, when you want to substitute, you want to get numbers. You want to get like down to a y equals or an x equals, because then you'll have exactly what you want to substitute in for the y or the x. So here I can get a y equals very easily just by adding 7x. So I'm going to take my first equation and change it to y equals 7x plus 22. Now, that's the first equation, y equals 7x plus 22. Now, you have to use the other equation. What we're trying to do is go from two equations with two variables down to one equation with one variable. One equation with one variable we know how to solve. So I'm going to take my second one now, 4x, and I want to get rid of the y. So it says plus 2y, but I know from the first one that y equals 7x plus 22. So that's what I'm going to substitute. 7x plus 22. But you can't write it this way. You have to write it in parentheses because the 2 is times y. The 2 is times this whole thing equals 10. So what I did is I substituted this for the y. The y became this. And now I have an equation with just x's, no y's. So now I can manipulate it and try to get the answer. This becomes 4x plus 14x. Remember the 2 is also times the 22 plus 44 equals 10. Okay, I'm running out of room here. 4x plus 14x. I'm going to erase some of this. I'm going to go back up here. I don't want to really erase that, so I'll do it right here. 4x plus 14x is 18x plus 44 equals 10. Now I'm going to subtract 44 from both sides to get 18x equals minus 34. Minus 34 because it's minus 44. Now, as you can see, they did not give us, I left out the x, didn't I? 18x equals minus 34. And they did not give us numbers that work out because now I have to divide by 18. I get x equals minus 34 over 18. You'll have to put that into your calculator. And of course, I don't even have my calculator on hand here. But it becomes minus, I don't know, that becomes the same as 9 into 17. Minus 17 ninths, whatever that is. Put it in your calculator and find out what it is, but it's not an easy number. Now, when I get a problem like this that doesn't come out with an easy number, it makes me think I made a mistake. So, I'll look back real quickly, make sure I didn't make a mistake here. Did I copy it right? Minus 7x plus y equals 22. Yeah. And 4x plus 2y equals 10. Yeah. And what did I do? I added the 7x. So I got 7x plus 22. Right? That's correct. Y. And then I put that in there. Doesn't look like I made any mistake, which tells me that they didn't bother. They just picked two equations without making sure they came out to nice numbers. Okay, so what do you do when you get this number? X equals minus 17 ninths. Once you have this number, you just put it back in either of these equations and you solve for y. And then you come up with the y. And you have a x and a y. So once you get the x, you plug it back, and it doesn't matter which one you choose, it should come out to the same answer. You plug it back in to get the y. Okay, we're going to move on to another one and hope that this one works out because I don't want to waste my time, especially since I don't have my calculator here. I don't want to waste my time doing these if they don't come out to nice numbers. Okay, number 4. X plus y equals 9, 2x minus 3y equals 8. Okay. X plus y equals 9. And 2x minus 3y. 2x minus 3y equals 8. So the first one's pretty easy to manipulate. We got a y already here. So I'm going to change that first one to y equals negative x, because we subtract x from both sides, plus 9. So now I know this is y. I can substitute this for the y in the second equation. So then you go to the second equation, 2x minus, we want to get rid of the y, so we're going to put this here, minus 3 times, parentheses, negative x plus 9 equals 8. 2x minus, now you got minus 3 times minus x, that becomes plus 3x. And you got minus 3 times 9 is minus 27 equals 8. This one I think might come out nicer. 2x plus 3x is 5x equals 35. How do we get x? We divide by 5 because that'll give us 1x. 5 in the x, 5x goes x equals, we divide the other side by 5, 7. Okay, there's x. What's y going to be? 7 plus y is 9. Well, you can subtract 7 from both sides. You just know y is going to be 2. So the answer would be 7 is x. 7 plus 2 is 9. Now, suppose you're not that sure. We could always just see, does it work over here? Well, 7 times 2 is 14, minus 2 times 3 is 6. 14 minus 6 is 8. It works. So you know you got the right answer because it works in both. And only one number works in both because the lines intersect in a single point. Very good. Okay, on to number 5. Y equals 3x plus 15. 5x minus 2y equals minus 26. Okay. Y plus 3x equals 15. And 5x minus 2y. 5x minus 4 minus 2y equals minus 26. Okay, so we take that first one, we change it to y equals minus 3x plus 15. And we're going to substitute it in the second one. So we got 5x minus 2 times what? What's y? Minus 3x plus 15. Minus 3x plus 15 equals minus 26. So we get 5x minus 2y times minus 3x is plus 6x. Minus 2 times 15 is minus 30 equals minus 26. 5x plus 6x is 11x minus 30 equals minus 26. This isn't going to work out well. We'll see. We get 11x. We add 30 to both sides equals 4. X equals 4 11ths. We divide both sides by 11. Is that a nice number? No, that's not a nice number. Then we can substitute that in here. 3 times 4 is 12 11ths. Y plus 12 11ths equals 15. Messy, messy, messy numbers. Well, I guess we could always check and see if they have the answer like that in the back. But anyway, I didn't come up with a nice answer, so I'm going to just go on from here. Assuming it's right and I didn't make a little mistake, but we'll go on because my camera's running out of memory here. Okay, 10x minus y equals negative 1, y equals 12x. 10x minus y equals what? Negative 1, I said? 10x minus y equals negative 1, y equals 12x. I'm going to use this first one as for my substitution because y is already set up to 12x. That looks like a nice easy number. So I get 10x minus y is 12x. 12x, oh, I forgot my x. 10x minus 12x equals negative 1. Now, 10x minus 12x is minus 2x equals negative 1. Divide by negative 2, x equals negative 1 over negative 2 is 1/2. That's my first answer, 1/2. If I plug it in here, let me put my answer 1/2, comma. If I plug it in here, 1/2 times 12 is 6. 1/2, comma, 6. Okay, does that work? Well, let's see. 1/2 times 10 is 5 minus what is negative 1? 5 minus 6 is negative 1. So that does work. Okay, that was for number 6. Okay, number 7. Where does the line with the equation x minus 2y equal 4 intersect with the line with the equation 6y plus 5x plus 4? Where do these two intersect? Well, when you have multiple choice, it's a whole different story. When you don't have multiple choice, you have to find the point of intersection. You have to do the math to find it. Or you could try guessing around, but it's kind of hard because you're guessing two numbers. Well, you're guessing one number for x and finding a y that matches in both. But when they give you multiple choice, you know that one of these has to work in both. So what you do is you just try it. X is 2. 2 minus what is 4? 2 minus negative 2 is 4. So y has to be 1. 2 minus, y has to be negative 1. 2 minus negative 1 times 2 would be negative 2. 2 minus a negative 2 is 2 plus 2. So y is negative 1. Oh, that one works. 2 plus 2 is 4. How about this one? 3, and it's minus 2 times minus 2 is plus 4. 3 plus 4 is 7. That one doesn't work. No, not 4. Let's try negative 2. Negative 2 minus 2 is negative 4. Doesn't work. And then negative 1. Negative 1 minus 4. 2 times 2. Negative 1 minus 4 is negative 5. Up, A was the only one that worked. Had to be A. Because that worked. It's the only one that worked in the first equation. These didn't even work in the first equation. I thought a couple of them would work in the first equation, and then we'd try see which one worked in the second. We didn't even have to go to the second. This was the only one that worked in the first equation. Usually on a problem like this, like 3 of them at least would work in the first equation. And then you would try, or 2 of them would work in the first equation. And then you'd have to see which one worked also in the second equation. We didn't have to go that far. Same kind of problem. Where does the line with the equation y minus x intersect with the line with the equation y equals negative x? Y equals x means the x and the y are the same. Only this one has the x and the y the same. Again, too easy. They should have had a 1, 1 or a negative 1, negative 1. They didn't even do that. So there's only one that meets the first equation. If they had put negative 1, then we would have put it here. Negative 1 equals negative 1. That's positive 1. No, that wouldn't have worked. Only 0, 0 works in this equation. That's the point where they intersect. Where does the line with the equation y equals negative 2 intersect with the equation? Well, we know y has to be negative 2. So D is wrong. It has to be one of these, right? Let's see. Okay. So if y is negative 2, we get negative 2 times 3 is negative 6. Negative 6 is equal to 2x plus 3. So we subtract 3 from both sides, we get negative 9 is equal to 2x. And then we divide by 2, we get x is divide both sides by 2, negative 9 halves. Negative 9 halves. Where is that? Right there. Negative 9 halves, negative 2. C. Which of the following is the equation of the line that intersects y equals 4x plus 2? Which one intersects? I thought all lines intersect. Oh, wait. If they have the same slope, they don't intersect. They're parallel. So if we're looking for lines that have the same slope, and they're not good. So here you want to change it to y equals. Remember, you have to have y equals. You'd have to divide by 2. 8 divided by 2 is 4. The slope of this line is 4x. It's the same slope, so they're parallel. They don't intersect, not A. Slope of the line, 4x. Y equals slope of the line, negative 4x. That one's different. Here, you multiply by 2 to get y. 2 times a half. 2 times 2 is 4. 4x. These three have 4x. This one's negative 4x. We want negative 4x. We don't want the same slope because it has to intersect. So that would be the one that intersects. Okay, so you have a whole page of these, okay, these in which you want to find where they intersect using substitution. So hopefully these all work out. But what you always look for is you look for y equals or x equals, or a single y or a single x, so you can do substitution. So this one, we'd have y equals 6x minus 11. So we can substitute that in the second one. We have negative 2x minus 3 times 6x minus 11 equals negative 7. So we get negative 2x minus 18x. You get minus 3 times minus 11 is plus 33 equals negative 7. Negative 2x minus 18 is minus 20x. And you're going to subtract 33. Minus 33 minus 7 is minus 40. Oh, good, it works out. You divide by negative 20. Divide by negative 20. And you get x equals 2, positive 2. So now we got x is positive 2, right? How do you get y? You just put it in one of these. If I put it in this one, 2 times 6 is 12, minus 11 is 1. If you want to check it, put it in this one. 2 times negative 2 is negative 4, minus 1 times 3 is 3. Negative 4 minus 3 is negative 7. It works. 2 comma 1. Okay? Here's a y equals, so you can use this to substitute here. Y equals, you can use this to substitute in there. Y equals negative 2. That one's real easy. You just put it right in, negative 2. I want to show you this one because number 8, you don't have a y equals, but you have an x. So I'm going to use that one. I'm going to change that to x equals 11, and I add 2y to both sides, plus 2y. Now I'm going to substitute it in here for my x. So I'm going to get rid of the x. Negative 7 times 11 plus 2y minus 2y equals negative 13. So in this one, we're solving for y. Negative, oh boy, it looks big though. Negative 77 minus 14y minus 2y equals negative 13. We get negative 77 minus 16y equals negative 13. Okay, we add 7 to both sides. We get negative 16y. If we add positive 77 to negative 13, we get 64. And then we divide by negative 16 by both sides. We get y equals negative 4. Now, if y is negative 4, we can plug it into this one maybe. If y is negative 4, you get negative 4 times 2 is negative 8, minus negative is plus 8. You get x plus 8 equals 11. Subtract 8, you get x equals 3. So our answer is 3 comma negative 4. Okay, you can try it here. 3 minus a minus 8 plus 8 is 11. Minus 21 minus negative 8 is plus 8. Minus 21 plus 8 is negative 13. It works anyway. There you go. Okay, so I'm going to run maybe one or two more until my my camera runs out of memory. Okay, let's do this one that looks kind of simple. Negative 2. Okay, so 4x minus 3 times what? Negative 2. It becomes plus 6 because I got negative 2 times negative 3. It's plus 6 equals 18. For x, I subtract 6 from both sides equals 12. X divided by 4 equals 3. Put the 3 in here. Well, you can't put the 3 there. But we already know why. It's negative 2. So the answer is 3, negative 2. We don't even have to, if we put it in there, we get 12 minus 3y equals 18. We subtract 12, we get minus 3y equals 6. Y has to be negative 2. You divide by minus 3, you get negative 2. Okay, 3 comma negative 2. So I will leave you to work on these and check your answers in the back. Okay, here's another one where we can substitute the x. Let's try that one. We'll do just this one here. X equals 1 minus 3y. I subtract 3y from both sides. Now I'm going to put it in here. Minus 3 times 1 minus 3y minus 3y equals negative 15. Negative 3 times negative 3 plus 9y minus 3y equals negative 15. So you get minus 3 plus 6y equals negative 15. You add 3 to both sides, you get 6y equals negative 12. Divide by 6, you get y equals negative 2. Plugging that back in here, negative 2 times 3 is negative 6. Blank minus 6 equals 1. You could add 6 to both sides, you get x equals 7. 7 comma negative 2. 7 comma negative 2 would work in this one. That was one I did, right? Yeah, okay. Anyway, I'm going to leave you to try these on your own. But again, a thing to remember, you have multiple choice. If you had a problem like this and said, what's the point of intersection? You would just try your points in the equations and find the point that fits into both equations, must work in both. That's the point of intersection. Okay, because substitution can be a little involved. And I don't know if they're going to give you something so involved on a GED test. Good luck.